Hello everyone. Today we are going to learn about how to draw free body diagram to find the total forces acting on a body at that particular instant. So, what is free body diagram? The diagram showing all the forces acting on a object at a particular instant is called as free body diagram. So, what is free body diagram? The diagram showing all the forces acting on an object at a particular instant is called free body diagram. So what is free body diagram? A diagram showing all the forces acting on an object at a particular instant. Okay, so this is free body diagram. So let us see few cases and draw a free body diagram and learn how to draw a free body diagram. Example, try to draw a free body diagram along with me. A box is at rest on a table. So what happened here? A box is at rest on a table. So let us consider this is a top of the table or surface of the table. So box is there here, and what are the forces acts on this? First one is gravitational force. So next upwards, normal force. Normal force. So normal force is always equal and opposite to the gravitational force. So what happens? This box is at rest, right? If these two are balanced, then what happens? Net force on this box is what happens? These forces both are balanced forces, right? So we already learned if the forces acting on a body are balanced, then the box is said to be at rest, or if the moving body stays moving. Okay, so normal force and gravitational forces both are balanced, so net force acting on this box is 0. So what happens? This box remains at rest. Okay, so second case, try to draw a free body diagram. Free body diagram when a rightward force act on a body. Okay, so that the box moves in the rightward direction. So a rightward force is applied to the box in order to move it across the table with the rightward acceleration. Ignore, we already learned resist, air also resist the motion of the object, and also water also. So here in this case you have to ignore the air resistance. So let us consider this is the top of the table and the box. So again a normal force upwards, opposite direction to the normal force, and gravitational force. So this side we are applying rightward force, right? Force, and so always friction resist the motion of the object on the surface of the other object. So friction is very less, that's why compared to the rightward force friction is very less, that's why box moves in the rightward direction. If the friction is greater than this rightward force, what happens? This box stays at rest. Okay, so normal and gravitational force both are equal. So what happens in this case? The box moves in the rightward direction. We are ignoring air resistance. Next, one more case. Let us take one more case and try to draw a free body diagram. Try to draw along with me. A car moving with non-uniform motion. A car is moving with a non-uniform speed along road. Okay, so let us consider a car. So downwards, what is this? Gravitational force. Next, normal one and normal 2. Next, this car is moving in this direction. So force applied by engine is F. Okay. So if the car is moving in this direction, in which direction frictional force acts? In this direction. So this is a frictional force. So N1 and N2, what are these? N1 and N2 are normal forces. Next, small f is frictional force. Who applies here frictional force? Road. So F is force applied by engine. And W is nothing but gravitational force. So you already know what is x-axis and what is y-axis. This is the x-axis and this is y-axis. So let us find the F net along the x-axis. Net force F net along the x-axis is equal to, x-axis means in the horizontal, so small f minus capital F. If the force is acting in this direction I said to take this is in the positive sign, with the positive sign. If it is acting in this, then it is negative. So small f minus capital F, this is a F net along the x-axis. F net along the y-axis is equal to N1 plus N2 minus W. Okay, the forces acting upwards are positive and the force acting downwards is negative. So these are the net forces acting on a car which is moving uniform with a uniform speed along the road. So now you got idea how to draw a free body diagram, right? So what are the forces acting in which direction? So object is moving in the which direction? According to these details you have to draw a free body diagram. So now let us see what is pressure. So till now we learned forces, types of forces, what is contact and what is non-contact force and all this, right? So try to learn now pressure. So what is pressure? So let us take a pen. So I'm taking this. Try to do like this. Do you feel any pain? No. Again take out the cap and again this sharp edge on your palm side. What happens? You will feel little bit of pain. Why? So in the first case what happens here? Area, okay, intersecting area is more, right? In the second case what happens? Area is very less. So pressure is nothing but what? Force applied per unit area. Area is called pressure. So pressure is equal to what is formula? Pressure is equal to force by area. So what are the units? SI units is equal to force units. What are the force units? SI units, Newton, right? So what is the units for area? Side into side, right? If you take any area, you will get in square meters or square centimeters. So I'm taking meters, then meter square. So Newton into meters power minus 2. This is a units per pressure. Okay. So area you will measure in meters or centimeters. So square meters. Newton. Force Newton. Force units are SI units for force is Newton. Okay. So just now we discussed. So let us take one more example. While cutting vegetables, you observe the knife. Are you going to use the sharper side or blunter side? Sharper side. If you observe sharper side, the area is very less, so that you can cut the vegetables very easily. Sharper side, what happens? Area is very small, so pressure is directly proportional to force, and pressure is inversely proportional to area. Inversely proportional is nothing but what? If area is increases, then what happens? Pressure decreases. So in the denominator side, larger value results in a number which is very small, right? So if area is very less, then pressure is more. Okay. So for knife or knife, observe, and for even safety pin, you observe cross sectional area. The edge side you observe area is very less. So area is very less means you feel the pain or impact is very high. So to cut vegetables you use sharper side than blunter side. Sharper side area is cross sectional area is very less, so that's why pressure is very high. You can cut the vegetables very easily. So and also you can see in old movies, in railway stations porters carry luggages, right? They use turbans, or you can call in Telugu talapaga. So why they use these turban or talapaga? To increase the area. Okay, if you keep directly a box or a suitcase on your head, you will feel more hurt. Okay, so to carry heavy luggages they use turbans on their head, so that these contact area is high, so that they carry this luggage very easily. And on the road you can see large lorries carrying heavy loads use many tires, right? You can see for normal lorry two pairs of tires, but here lorry which is carrying heavy load you can see more than two pairs, so that they increase the area. If they increase the area they carry the load easily. Okay, so force is nothing but what, pressure is nothing but what, force applied per unit area. So let us see, if you want to push a book you have to apply force, and if you want to push a wall, what happens here? If you apply force on the wall, what happens here? There is no change in a position of a wall. Okay, so if you want to push a wall, so you have to suppose you are applying force on a wall, can that wall moves? No. Here area is more, right? So more area means you are applying, so what happens, there is no movement. So same force apply on the book, you can move the book very easily. So now you understood how to draw free body diagram and also what is pressure. Okay, so that's all for in this class. So let us try to do the homework questions. If not getting, I'll explain in the next class. So today's homework follows free body diagrams only. So I'll everyone must and should submit your homework.